Here in this presentation, we'll be talking about light, as well as electromagnetic energy and the different forms that electromagnetic energy can take. At the end of this presentation, we will focus more on the part of the electromagnetic spectrum that we can actually see, which is visible light. All in preparation for an experiment that we'll be doing about visible light. So we already learned that waves that do not require a medium are called electromagnetic waves. You might also remember electromagnetic energy, which was energy that travels in the form of waves. So this all includes the electromagnetic spectrum, of which visible light is a part of, like the sunlight and the rainbow. Aside from visible light, there are other forms of electromagnetic energy that we can find on the electromagnetic spectrum. These forms include radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Here off to the side, you'll see the electromagnetic spectrum, and you're starting to notice that it can include quite a bit of information. So the electromagnetic spectrum is the range at which electromagnetic radiation exists according to frequency and/or wavelength. Here you should be able to notice at the bottom we have a wave, so we have wavelength, and it also tells us the different frequencies that the forms of radiation have. When you see the electromagnetic spectrum, there are two things that are really important that you have to remember. The first thing is how to read it. Now here, you should hopefully notice that this electromagnetic spectrum is organized just a little differently than the one we saw last. In the last one, gamma rays was on your left, radio waves was on your right. Here, it's the opposite, so the entire spectrum has just kind of been flipped over. All the information is still correct, but you just have to be careful when you're reading your electromagnetic spectrum that you're reading it correctly. All right, radio waves are always going to be bigger than microwaves, but don't be confused just because they're in a different order. The second thing that you have to remember of the electromagnetic spectrum is the uses for each type of electromagnetic radiation. We'll go over those next. So the different forms of electromagnetic radiation all have many different uses. Radio waves, as you might notice, have to do with radios. They also have to do with radars, satellites, and broadcasting, so they are largely used for transmitting messages. Microwaves are found in your regular microwaves. They're used to heat food. They're also used in your phones for communication. Infrared is heat or thermal imaging. Think of those night vision goggles. Those use infrared technology. Visible light is light, rainbows. It also is found in things like telescopes and microscopes because they allow us to see images that are really far away, or they allow us to see up-close images of things that are too small to see with our regular sight. Ultraviolet is found in tanning rooms. It's also used to check for counterfeit money and can also cause sunburns. X-ray are used for X-rays, so either for security imaging or medical imaging to find out if you have a broken bone or not. And finally, gamma rays can be used to sterilize medical equipment. Think about where we have the goggles hidden in our classroom, and they're also used for cancer treatments. Now we're going to start to focus a little bit more on the form of electromagnetic radiation that we can actually see, which is visible light. And we're going to talk about the different properties of our light waves. The first one being reflection. This is when light bounces back in the same direction that it came from. And that's what we see here. We see the light coming down from the sun and bouncing back at the same angle. Refraction is when light bends. So that's what we see here in both of these pictures. In the first picture with the man, light enters the water, leaving the air, so it's changing medium. And now light is bending. So he's seeing the fish in a slightly different position than where the fish actually is because, again, the light is bending, the light is refracted. So if he wants to catch that fish, he needs to account for that light bending. That's also what we see here with these two cups and the straws. It looks like the straws are bent inside the glass, but if we were to pull them out, we would find that the straws aren't bent at all, it's just refraction. There's also absorption. Absorption happens when the light wave is more or less absorbed completely. Some of it does get converted into thermal energy or heat. And that's what we see here in these two pictures, the light waves entering the next medium, but then disappearing or being absorbed. That's the reason why we can see specific colors for different objects, right? I know that I'm wearing a red shirt. Why? Because all the colors except for red have been absorbed into that shirt, and that's why I see it as red. That's what we're seeing here on the screen. All the colors of the rainbow are being absorbed into that green block, except for the green light ray that we're seeing is being reflected back out, and that's why we see that as green. We also have to think about the object itself. Some objects are translucent, where we can see through them, but not completely. And so that's what we see here in these two pictures. With the blue, we can kind of see that there are other objects beneath it, but we can't really see very clearly what they are or how many of them there are. And with the next picture, we can see the outline of the woman, but we don't know exactly what she looks like. So we can see the object, but it's not clear to us all the details about that object. Another way that we can describe objects is if they're transparent or not. So this means that it can be seen clearly all the way through because all the light is passing through it. It's not being absorbed, it's not being reflected back. So that's what we're seeing here, right? With the little glass, we can see straight through and we can see the building behind it. With the piggy bank, we can see straight inside and we can see all the money that's inside that piggy bank. It's very clear. And finally, opaque. Opaque are objects that don't allow light to pass all the way through. It's either absorbed or reflecting all the light. And so that's what we see here with the giraffe. In the transparent panel, we can see everything about the giraffe, the grass behind him, all of that is very clear. In the center panel, it's translucent. So we can see some details. We know that it's still a giraffe, but we can't see every single detail like we can in the first panel where it's transparent. And in that last panel, it's opaque. We can't see the giraffe anymore, but we know that the rest of him is behind that opaque panel. And then finally, in the picture of the man is himself opaque. Light isn't passing through him. There isn't any dots of light, in the middle of his body that we can see through. There's just the light around him creating the shadow, but he himself is opaque.